Hey, welcome back everybody, and welcome to this new episode or this is the third episode of data management and asking ChatGPT about different concepts. Well, through this set of videos, I am also sharing my knowledge. I have already 7 years of experience working with data. I consider myself to be a data engineer as well as a data analyst. I am Scrum certified, I am business analytics certified, and then over the period, what knowledge I have gained, that knowledge combined with the standard definition of ChatGPT, we are discussing about different data governance definitions or different elements associated with data. Well, everyone cannot become a data engineer, and everyone cannot do data engineering. It's not just connecting data with each other. People think that they are data engineers, but over the period they have done something in Excel or something in SQL or something in Python. They think that they're data engineers, but data engineer goes a way level deep than what people can imagine, and that is why there is a lack of confidence. People cannot maintain it, they cannot work with it, they outsource the work, and that is the struggle in many of the organizations where people that is a struggle between the learned people and the unlearned people, people with knowledge and people with less knowledge, and the fear. That is how the stakeholder management comes into play, and the friction is there. Anyways, apart from the politics itself, data engineers must know set theory before they start building up anything. Why? Because of this. Suppose if I am doing a union, or if I am doing a left join, right join, for example, we already saw in the previous classification of the SQL commands that the joins are data manipulation language, and if I am doing some manipulation, then I should know what is the cause and what is the outcome of the manipulation. If I do outer join and the intention was to do left join, then I end up in unnecessary data and chaos in the table itself. So regarding set theory, if I go to Google, then I will get a bunch of these difficult definitions along with the history, etc., etc. But then I don't want to go deep into that, because this video, the purpose of the video is to talk with ChatGPT. And then I already asked a question that what is the linking between set theory and the data engineering? Well, it's a beautiful answer that ChatGPT has given. And it's first the definition of the set theory. Sets are like tables, like this is a set, this is a set, this is a set, this is a set. So then sets are like tables, and the set theory is a branch of mathematics that deals with collection of objects or elements known as sets. In context of data engineering, how the application is, these are the applications. First of all, any operation you do, like any data manipulation language one writes, like union or intersection or anything, it has a consequence. So if one doesn't know about what a union or a subset, or what a union does, or what an intersection does, then yeah, God will save that company from the consequences. And so it's like if we are strong in mathematics, then we are already very strong in the data transformation, data manipulation. For an example, I will be showing some codes in the we will be performing some real tasks with the set theories, and but then let me finish this one. Set theory also helps in data normalization. It helps in data analysis as well as in the data modeling. So at least if nobody has an interest in set theories, but please I will tell that if you are into data engineering or data manipulation, if you tell yourself as a kind of a data governor, then please go through the set theories once in life to have all the knowledge. Okay, so then set theory, yeah, you guys can Google more and know about it more. But then the example of today is not the joins. I will not discuss about the joins. I will discuss about the union one. And the union is that, for example, the people who are doing writing codes in SQL, then they already know that if I do a union, and then what happens. So here I have a data3 table, and data3 table has two empty, two null values, and these are the records. Data 1 has similar data as data 3, like Kuna and Kudu and Kakuni. All these names are same, but then the address column has a kind of a different record here. And then data 2 column, it is a kind of a subset of data 1, where the same data is repeating, or it is the same data itself. There are 12 records here and there are 11 records here, as you can see, guys. Okay, so let's do first the union of data 1 and data 2. What happens there? If I do a data 1 and data 2, I see that data 1 had this many records and data 2 had this many records. The only difference is that in data 2, I see here these records are different than these records. So then some of the records are duplicates, and some of the records are some of the records are unique. Like these records are unique, but then the names are different and names are same and phone numbers are same, but the addresses are different. But remaining these records are the same in, I hope so. Yeah, I see here that remaining records, these two records, this set of records are the same. Yeah, it's the same. So then if I do a union, I expect something like this. So there are 17 records. And did you see one thing? The records which were not in data 1, means the records which were duplicate are not here, but then the non-duplicate ones are here. So this is the advantage of union. Union eradicates the duplicates. Many people don't know about that. Many people think that union only combines the two tables, but then it combines the two tables by removing the duplicates. This is the full definition of union, and one can only know if they know about set theory itself, because in set theory these things were already taught in the school. What happens when there is A union B? As you see, 1 2 3 and 2 3 4, if there is a union, then it brings only the 4 here rather than, and removes the duplicates. Whereas in A intersection B, those are like left join, right joins, it only brings the intersection. Okay, so moving forward, so please guys, if you aspire to be a data engineer, then at least you should spend some time in knowing what the set theory means, and then incremental loading, all those hi-fi things can come. You can create the codes for them easily then. Okay, we also saw the codes, and then now it's time for keys. We already discussed about primary key, foreign keys, compound key, composite key, surrogate key, so I don't need to go into the details here. Maybe people can go into this website and they can read the definitions there. But primary key and unique key, remember that the null values. Otherwise, both are almost the same. And composite key is like combination of 2 or more columns. Okay, I also wanted to make a concrete example of the difference between unique key, primary key and foreign key versus not null in the column. So then these are some sample codes that I have to show you guys how you can create a not null column. Imagine you are creating a table that has 3 columns, that is ID, last name and first name. And either you can declare this ID as primary key, either you can declare this ID as unique key, or either you can declare this ID as unique not null, and either you can declare this ID as not null. Not null means it will not allow null, but it will allow duplicates. Unique not null means it is like a primary key. It will not allow null, but all the records are unique. Primary key is like all the records are unique, not null. So this is the difference between unique key, primary key, and not null key. But the difference between foreign key and primary key is that, for example, if there are 2 tables, that is persons and orders, then if I have to connect person and orders, like if I have to do data integration, not data transformation. Data transformation is done on 1 table only. If I have to do data integration, and then I need the foreign key person ID in this order table itself, and this is the linking pin between the 2 tables where these records can come to this record, and then we can have one table with all the all the columns, and then that can be used, and that is called denormalization, and that can be used for reporting purposes. I will not, I don't want to go into the details of creating or executing these queries in SQL Server Studio Management. I think you guys can already try it out. Okay, and the order is that for creating a foreign key, it needs a reference, and a reference is only available when this table is already there. So first we have to create a child key, and then one has to create the parent key. Means this is the parent and this is the child. So this is a child table and this is a parent table. So one has to create the child table first and then the parent table to have foreign keys assigned in the table. Okay, and this is helpful for creating star schemas, and people who are experienced with creating databases, they already know it, so I don't have to describe much further on this. Okay, moving forward, indexing. Indexing is, for many of the people, I will say it is necessary, or many of the people, it is not necessary. For me personally, I don't create it because indexing occupies some space in the database. We'll go through this in detail. There are 2 types of indexes, that is the clustered index and the non-clustered index. A clustered index is that if you have already created a primary key, then a clustered index is automatically created if you have created a primary key. So this is easy peasy. But a non-clustered index is mainly used for reporting works. Like when reporting is like you have to get the data. So getting the data means querying the data. And then if you want it to be fast, then a non-clustered index has to be created. And how that index has to be created, now I'm going to show it now, guys. And one null value can be added to non-clustered index. So this is something extra. I have the codes here. What I did, I showed already the data 3 here. Data 3 has 4 records and then 4 rows, and in the 4 rows there are 4 names, different names, and the phone and the null values here. What I did to create a index, the code goes like this. You have to assign that index to a certain name. So then to the name column, I declared that this name column should be a non-clustered index in the name of IDX name. Means I have to name this non-clustered index, and then I created this index by naming the name column in the data 3 as IDX name. Okay, I created it. When I create it, how can I see it? Do I see anything here? I don't see anything here. So where was the index created? Well, the index was created in the table itself, like you see the data 3, and inside the data 3 there are indexes, and here you see the index name. It's non-unique, I can create it, I can make it unique by declaring that column as unique, not null unique, but then I'm not going to do that. Okay, then IDX name is the non-unique, non-clustered index, and if I have to query now, and if I have to see the properties of this index, then I have to execute this select star where the object is this and this. This is the query that I have to execute, and then it gives me all the attributes of the non-clustered index that I created. And if I have to see what is the benefit of creating this index, is this is how. Suppose if I am making a data query language, that is if I'm making a select statement and I want to extract all the data of CUNA, then yeah, select star from this, and now though the name has been declared as a non-clustered index, the querying will be, means the records that I will get will be in milliseconds, or it will be very fast. And how I can check that? Explain is the command where okay, here it is not working, so then but then you can see the speed and speed of execution of the query through different techniques. And yeah, this is how, this is the benefit of non-clustered index. You have to assign it to a certain name, and then the query becomes faster. So indexing in database is sometimes necessary or some not necessary. Indexing means you are making the database bigger, and for now it just because we don't have terabytes of data, so then creating a clustered and non-clustered index doesn't matter for me, and then I don't care about that also. And because per year in my organization there we are generating around 4 million records, and then each month is like 200,000 or something, then so then it doesn't matter much, because the querying will be faster with this small set of data. Okay, so we read about indexing, we read about unique key, primary key, foreign keys and not nulls, and then we also discussed about the set theory. Now moving forward, query processing time. This is more of like a infrastructure point of view. I'm sharing this knowledge where a data engineer must have the knowledge to how to check the query processing time, because data engineer or data architect, people think that they are big data architects, but they are not. They are zeros. Data architect involves like you have knowledge of data storage, you have knowledge about processing time, you have knowledge about modeling, you have knowledge about how the data warehouse, data mart looks like. Also, you should have experience with it. It's not about, because as I said, in Google, I can find multiple data architects, thousands of data architects are shared. I can pick anyone, I can start querying on it. But that is how not the business people should work with. And people at the end, if it is difficult, then they outsource the work. But that is not how it should be. So how a query is working, we can check the query, review the query through different techniques, and set statistics profile on in SQL Server Studio Management, explain, analyze in SQL. There are many things we can do to check the query performance, and the one that I use always is this one. As I said, I wrote the query like using a where command, not by a nested query, something like this. And yeah, if I can yeah, correlated queries should be avoided. It searches row by row, impacting the speed of the query. Suppose this table is like 8 million and this table 4 million, then it will take a lot of time. So rather than that, use a where statement and you are easily done there, because it will work in, it will be bounded to one table only, that is the order table. That's it. If there are multiple queries running on the server, then also querying could be take some time. If your hardware is of old fashioned, then also it can take some time. This is just for something to share and to have some information about it. That's it, nothing much. Okay, now it's more of like an overview. A data engineer should know about the design of the data warehouses as well as the data marts. And generally, if you have a changing dimension table, then you should use data vault concept, because it records restores the historical records through means of hops and satellites. I'm not going to go into the details, but then you can search Google, watch YouTube videos or watch any tutorials how to create a star schema, snowflake schema, or a galaxy schema. Generally, I work with galaxy and the star schema. These are easy, and making it or having a denormalized data and querying it to reports is for me is easy. And one of the main difference between relational database and data vault is that data vault is difficult to maintain because, for example, if I am going to create a data vault on these 1, 2, 3, 4, 5, 6 tables, then data vault will make these 6 tables to 18 tables, because it creates multiple of 3 or multiple of 2, many more tables, because here the satellites and hubs needs to be created, and the querying is also not that easy. Also, there are multiple things will happen there, and people can go crazy about this, and at the end they think we have to outsource all the work, but that is not the case. Changing dimension concepts can also be built in relational database, where the number of tables will be limited. It will be like increase from 6 to 8. So the number of tables are less in the relational database, and then the data warehouse database or data warehouse, you can easily maintain it and monitor it if something goes wrong. So the number of tables are less, and it is easy to maintain also there. That is more of a difference between database and relational database and data vault. Okay, moving forward, I wanted to share this information that DB schema is one of the tool that can be used for data governance. Means, for example, if somebody tells you to do data profiling, then you can install this app, and nowadays DB schema, and there is a kind of a small learning curve there, but then that tool can be used to see or to create data models, etc, etc, etc. It's a free tool. And also it will help you to learn which attributes are where, etc, etc. Okay, I use Azure Data Factory a lot, and Azure Databricks, the whole Azure subscription a lot. Azure Data Factory nowadays, from on-premise we are moving towards cloud, and then orchestration or making the job run automatically. That was a big challenge in the on-premise server, but now with Azure Data Factory I can set a trigger, and then orchestration can be done easily. Azure Data Factory also gives me a provision for writing SQL queries, and then it looks something like, there is a query option in the copy data element, and there I can write my query. So it also gives me provision to write queries in Azure Data Factory. Azure Databricks is more of a canvas where many people with multiple programming language background can work together. For example, in one canvas, people can write Python codes, and can write SQL code, can write JSON or R language, etc, etc. It looks something like this. Something like this, where one can write SQL codes as well as Python codes together in one canvas. It's like SQL, it's like an Excel sheet when you shared or put it in the Teams folder. So the multiple team can open that Excel, and then you will see different profiles who are active and working in that SQL file. There is quite a big learning curve in Azure Databricks. I use Azure Databricks a lot, and the reason why I use it is that it gives me the processing power, and then it's based on distributed cloud, and then through Spark session. Spark is like the engine, and then it has the Hive database. The Parquet files are one has to know about the Parquet files. I think if people know about something, that these Parquet files are column-based files, are column-based. Well, if I go to my SQL database, and then if I am querying something, I get kind of these tables. This, if I will alter and store some data here, then the database design itself is a row based design, but Parquet file design is a column based or advanced design that is column based. The advantage is that if I store 1 million records in SQL database, then the size will be around 400 MB. But then if the same file I store it in Parquet file, it will be like 50 KB or 1 MB max. And the design is based, or the architect is based on column based format. That's why these files are highly compressed, and if it is highly compressed, then querying from those files are very fast. And that is why the SQL, if I use Databricks, then performance is 20 times faster, or the processing speed, or if I have to process 1 million records or 8 million records or 1 terabyte records, the processing much faster than the normal SQL which I write in Azure Data Factory, which is based on ISO some standards. Okay, Azure Data Lake, whenever I write codes in Azure Data Factory, then the unstructured data is stored in the Azure Data Lake. For more information, you can see Azure Data Lake, what are its uses. Azure Data Lake is kind of a like like a storage area, and in this storage area you can unstructured, structured, all the data, semi-structured, all the data can be stored here, and then from there you can query it. It can be in form of SCSV, Parquet, you can do partitions, a lot of things can be done there. Azure SQL, to my understanding, or to my what I do is that, to my experience, I only store the structured data in SQL, because the data which is stored in the SQL environment or in a SQL database, these are of very high size, and then you always want to limit or not bring the staging area files there in Azure SQL. And Azure SQL is easy to connect with many Power, means everything is easy to connect, all the API connections are ready-made available, but then yeah, SQL, if I have to query from SSMS to Databricks or SQL database, I will prefer SQL database. And if the structured data is stored somewhere else rather than in the same Azure Data Lake, then it is mentally it is like, okay, structured data is somewhere else, semi-structured data is somewhere, unstructured and semi-structured data is somewhere else. So then number of tables are less, and then less garbage in the database itself, or data warehouse itself, or data mart itself. Okay, moving further, Azure Analytics Services is a step further. It's the part after data engineering. So there is a hard cut between data engineering and analytics services. So data engineering team can be different, and data analytics teams can be different. Analytics work starts from data engineering, and there the concept of common measures model, like for example, if you create a measure in Power BI, then that measure is stored in that Power BI itself, but then that measure could be used, like net revenue or something, could be used across the organization on for the same table that you are querying on. So then Azure Analytics Services facilitates to have common measures across the organization, and that is the benefit of it. I'm trying to implement this in the organization. Let's see how it goes. And at last, the SQL Server Studio Management. It's like a intermediary between the database and or kind of like a canvas where I can play on with multiple selected, or can do some transformation or do some integrations, and I can check before doing something in Data Factory, Data Lake. I can do many things here and can see what is the outcome, and then that query I can run it in the Data Lake. It's like a studio where it's like a canvas, or it's like a place where I can play around with data, something like that, better control over data. At the end, visualization, right now I work with Power BI, but then you can use Tableau, you can use Python and Streamlit to create dashboards, and that is based on the choice people have. Okay, this is what I wanted to share in this 3-part video. I hope people liked it. And this is to educate many of the people who confuse between definitions, and people who don't know about SQL itself, because people are busy in writing SQL codes rather than they know how it can be grouped or what are the terminologies used among the big developers. This is also one of the effort of mine to make people more educated. Then set theories, one should definitely know keys, one should definitely know indexing, processing, and different type of modeling and the tools itself. So this makes someone qualified to be a data governor and then to manage the data team. But overall, people lack a lot of knowledge, they lack experience, and all these things are a specialization in itself only. This, in one lifetime one cannot achieve all those knowledge, but they can grab the theory, but they cannot gain experience on it. It's only if you work overtime or during Saturday, Sunday, then you can have overall knowledge of all these things. Okay, with that being said, guys, have a nice day. And if you have any comments, or if you say I said something wrong, then please ask ChatGPT. So I will conclude by thanking you, ChatGPT, and with this, my life has changed, my learning curve has increased, and then yeah, thank you, ChatGPT, for helping me, and all the credit also goes to ChatGPT community and the team itself. Have a nice day, guys, and we'll see each other in the next video. Till then, bye bye.